In April 2021, the Natanz uranium enrichment plant in Iran suffered an abrupt blackout. Explosives had been detonated inside the heavily guarded subterranean facility, destroying its power distribution and wrecking the metal centrifuges used to enrich uranium. This is textbook industrial sabotage. It involves explosives, concussive force, and obvious physical violence to achieve a concrete military objective. But 15 years earlier, that exact same facility was targeted in a very different way. A malicious computer worm known as Stuxnet, a digital file barely 500 kilobytes in size, managed to tear apart these exact same metal centrifuges without a single gram of explosive material. Lines of code were written on a computer, smuggled into an isolated facility, and used to exert immense, destructive physical force against heavy machinery. The Charter of the United Nations outlines the basic rules of modern international relations. Specifically, Article 2.4 prohibits sovereign states from engaging in the threat or use of force against one another. For decades, the international community understood force to mean kinetic military action. A state deploying troops, dropping bombs, or firing missiles across a border was clearly using force. But a piece of malware is entirely intangible. It has no physical mass, makes no sound, and exists only as electronic signals. When a state deploys code instead of artillery, the traditional legal framework struggles to categorize the action. Global security and legal experts had to confront a massive blind spot. They had to figure out exactly when a string of ones and zeros crosses the line into a legally recognized act of war. To understand how it crossed that line, we must look at how it bypassed security at Natanz. The industrial control systems running the centrifuges were air-gapped. They were physically disconnected from the internet to prevent remote hacking. To cross that physical gap, the attackers targeted outside engineering contractors who had authorized access to the facility. The malware lay dormant on the contractors' laptops until it was automatically loaded onto USB drives, which the unwitting workers then carried right through the front door. Once inside, Stuxnet relied on 0 days. A 0 day is a security flaw in software that the creator doesn't know about yet, meaning there is 0 time to patch it. Stuxnet was armed with 4 of these rare exploits, allowing it to jump effortlessly between computers. But it didn't steal files. It scanned the network looking for programmable logic controllers, or PLCs. These are the specialized microcomputers that directly operate physical industrial machinery. The facility's anti-aircraft guns and subterranean concrete walls offered 0 protection against a weapon carried in a worker's pocket. By insecting the PLCs, Stuxnet controlled the frequency converters, the components dictating the centrifuge motor's electrical flow and rotational speed. The code commanded them to spin beyond safe limits, then abruptly slammed the brakes. At hypersonic speeds, this created fatal internal vibrations. While it was tearing the hardware apart, Stuxnet ran a parallel operation. It intercepted the data flowing from the machines to the control room, feeding a pre-recorded loop of perfectly normal operating metrics to the scientists' monitors. Deep underground, vibrating rotors scraped against their aluminum casings, tearing themselves into metallic shrapnel, while operators stared at green lights on their screens. The malware blinded its victims, manipulating their perception of reality while it destroyed their hardware. The operation destroyed nearly 1,000 centrifuges, severely stalling the Iranian nuclear enrichment program. This matrix illustrates the scale and effects test developed by experts to evaluate violations of the UN Charter. If a cyber attack causes the exact same physical destruction or injury as a conventional explosive, it legally qualifies as a use of force. The international community now recognizes that a digital weapon can inflict the exact same devastation as an airstrike. Stuxnet was engineered with intense precision. It infected millions of computers worldwide, but only activated its payload when it detected the exact configuration of Natanz. However, the universal mechanism it exploited is exactly what currently regulates our domestic infrastructure: American power grids, municipal water purification plants, and public transit networks. When automated industrial sensors and controllers fail in civilian spaces, the results are catastrophic. In 2009, a Washington, D.C. metro sensor failure blinded a train to another stopped ahead. The resulting collision killed 9 people and injured 80 others. That event wasn't a cyber attack, but it proves the fragility of the systems we rely on. Today, the U.S. government continuously issues critical alerts and holds congressional hearings regarding severe, unpatched vulnerabilities in domestic infrastructure. Modern adversaries no longer need bombs to cripple a nation. They just need access to the fragile mechanical systems that keep our modern world functioning.